All right, so here's our pre-calculus problem of the day. So we're looking at a few problems here where we're using the laws of logarithms. We're going to expand these logarithms. A lot of times this will be helpful in solving equations or other graphing, other things like that. If we can either expand or contract, it depends on what is the most efficient or helpful, depending on the problem. So it's a good idea to have these properties memorized. So we'll just write these down here. So we have, for instance, log of A times B, we can expand out and write as log of A plus log of B. The base doesn't matter. So we could write base 2, base 3, base 5, base whatever it is. But whatever the base is, it's going to match on both sides of the equality. Then we have log of A over B would be log of A minus log of B. And then last one commonly that we use for this kind of thing, we'll say log of A to the n. We can bring this exponent down in front of the log and write n times log of A. So using these, we'll expand these three. So of course, log of 8 times x, we're going to use this first one and write this as log of 8 plus log of x. And so kind of what you wanted to get done here is you want single terms, I guess, either a coefficient, either a number or a variable, but we don't need anything multiplied together or divided, no exponents, anything like that. And once you get that, you would be done. Now this one, you got the square root here, square root of t to the fifth. So what you might want to do first before you expand this is to write that square root of t to the fifth as just an exponent. So that would be t to the 5/2. Of course, square root is an exponent of a half, and then of course with the 5, that would go in the numerator here. So we have t to the 5/2, and then we can just use this property here and bring that 5/2 in front. So we have 5/2 log of t. Then with this one, so now you got to be careful with these. Anytime that you have multiple parts of the argument here, the logarithm argument, you got to be a little bit careful. So the way I kind of do these, there are a couple ways to do this, but I think the easy way, anything that's in the numerator is going to have a plus in front of it. Anything that's in the denominator will have a minus. And that's the easy way to do it. You could write this out in a couple of steps, but it's really not necessary. So let's just do this all at once. So anything in the numerator gets plus, anything in the denominator gets a minus. And then we're gonna split this up. Like I said up here when we first did this, the answer that you want, you don't want anything multiplied together. Um, so 3s would not work. We need ln, in this case, ln of one thing plus or minus ln of something else plus or minus ln of something else. So so anything that you can split up, you want to be able to split up. Now, if you have something like ln of x plus 2, this you cannot you can't split that up. That is as simple as it gets. You just have to deal with ln of x plus 2. But whenever you have things multiplied together inside the logarithm function, then you can split them up. So practice these a little bit. They don't take too long to get proficient at, as long as you have memorized these properties. Plus, there are a couple others that we could talk about too, like log. Um, we'll just use log of 10 to the x, whatever it is. If the base of the log matches the base with the exponent, then that just equals whatever the exponent is. So things like that, and we can actually reverse that. Log base a to the log base a of b, we'll say, would equal b. So the log and the base will cancel each other out. And then, of course, other things like log of 1 is always 0, no matter what the base is, doesn't matter. So things like that. So as long as you get those things down and learning things like this comes back to what we talked about in, I think, his last video, the last problem of the day, where how do you convert that to an exponential function? So learning things like that, these become pretty easy. We can get pretty complicated with the expression in here, but it all comes back down to those basic properties. So if you have any questions or comments, please leave those. And if you want me to do any other problems, you can leave those in the comments as well.